Right, morning year 10. Today's lesson is just a quick recap back to some of the chemistry that you did probably last week, I think it was, maybe the week before, on energy changes. So you guys filled in this little Google quiz, which has been returned to you this morning. And I'm just going to run through some of the answers and then set you a quick educate to reassess and see whether or not you've picked up or learnt anything. So, our first question, true or false, energy is conserved in all chemical reactions. This is maybe a bit tricky because the word conserved is a bit of an odd word, but what that means is it's kept, it's not lost. And what you need to understand for your chemistry, physics, and biology is that energy cannot ever disappear. Okay, it can only be transferred from one form to another. So the answer there, energy is conserved in all chemical reactions, is true. If a reaction gives out energy to the surroundings, the products of the reaction have to have less energy than the reactants. So this again comes back to our reaction profiles. If they have less energy, okay, than the molecules you started with, then the energy, if you started with 200 joules of energy in the bonds and you end with 100, then that extra 100 has got to go somewhere. So it's going to give out energy to the surroundings and heat it up. The surroundings increase in temperature during a reaction. The reaction is exothermic. We said it's sort of the energy exits from the reaction. Is the reaction between citric acid and sodium hydrogen carbonate exothermic or endothermic? This is endothermic. Just something that you have to learn. In an endothermic reaction, the products are at a lower energy or a higher energy. Well, in an endothermic, the products, things that are made, have to be at a higher energy than the reactants because the endothermic reaction takes energy in order to get them up to there. Which of these uses an endothermic reaction? So some sports injury packs, they're the cooling packs. Okay, a self-heating drinks can will give out energy. So an endothermic, it can't be that. Activation energy. So this is the amount of energy needed by the particles to react. Okay, but it is the minimum amount. Again, it's a bit of a tricky question, that one. But it's the minimum amount of energy needed for the reaction to go ahead. Which of the following can be used to measure the energy change when a chemical reaction takes place? Again, a change in temperature. Hopefully, I think most people got that one. And then the last few, we don't always get a reaction. Explain why this is. So this is due to the fact that if the particles collide without enough energy, to meet the activation energy, the minimum amount, then it won't occur. So if they collide without enough energy, why do hand warmers use exothermic and not endothermic? Because we want them to give out heat to your hands. Okay, so an exothermic reaction will do that. An endothermic would take heat from your hands and cool them down. So that's not going to be very good. Give an example of a type of reaction that's exothermic. So here you really want to learn combustion, neutralization, or oxidation. Okay, those are the three types of reactions that we class as exothermic at GCSE. Okay, so here we can see this line is the amount of energy in our reactants. This is the amount of energy in our products. It is less here after the reaction than before. So this energy, B, that's disappeared effectively, it has to be given out. So this must be an exothermic reaction. Which arrow represents the overall energy change? We're going from this line here to this line here. So it is B. That is the overall energy change. And then the activation energy is here, A, this amount that's required. You have to put this amount of energy in to get up to here in order for our reaction to occur. So like I said, have a go now at the educate, and I hope that that's maybe clarified a few things for you.